Welcome to Hemp Foundation Talks, where we listen to the heartbeats of the hemp industry and learn the celebrations, challenges of hemp leaders and advocates from around the world. I'm Rebecca, International Business Officer with Hemp Foundation and your host. Today's guest, we have Robert Ziner. Robert Ziner is the CEO of Canadian Industrial Hemp Corporation, the company. He founded CIHC in 2016 after being sent to China by the Canadian Alberta government to determine if AI could be effective in building a viable and thriving hemp fiber industry in that province. Robert has a 30-year history in AI and advanced manufacturing technologies as they relate to natural fibers. He was in the lumber industry since 1974 and in 1987 partnered with General Electric's Factory Automation Group to develop an AI-driven, computer-integrated manufacturing application for secondary wood processing, which was patented in 1991. This technology redefined the economics of secondary wood processing, increasing production flexibility and consistency to help reduce production costs by over 50% and increasing value add by over 100%. After building a new facility in 1997, sales increased from 37 million a year to 240 million by 2001. CIHC's proprietary smart stock system is now globally patent pending. It redefines the economics of hemp stock processing by transforming it into hemp fiber optimization and includes the world's first automated hemp fiber quality control system. Robert is a recognized expert in fiber processing, optimization, softwood lumber, and hemp. Robert believes in the power of cyber physical engineering, structures and systems, recognizing that innovation is always first created in the imagination's virtual world to then be translated into existence. Hey, Robert, welcome to Hemp Foundation Talks. It's so exciting to have you here. I know that you have been just such a wealth of information. I think I even started following you a couple years ago. And the things that you're doing in the hemp industry to help move things along is really honorable and appreciate your work. And thank you for taking time to join us today. And please, let's start off with sharing a little bit more about you and why did you get into this industry in the first place and your journey along the way.
Well, thank you, Rebecca. It's a pleasure being here and having the opportunity to speak with you. I've enjoyed our previous discussions, and I'm very happy to speak with your audience today. I got involved in the hemp industry, I guess one could say when I was going back to school to do my MBA in 2001. We had some courses where we had to pick a new industry. Either in terms or an industry. One of them was to pick a new industry, and the other one was to do a research on a government interaction with a specific problem in the industry. Hemp had just become legal in Canada in 1998. This was 2001, just a few years later. I had read a few things along the way that I thought were interesting. My background was in the wood processing and building materials industry. And what happened was that I had the opportunity to use the hemp industry, therefore, in my two projects. And one of the first things that I read was that the hemp fiber, the bast fiber, was stronger by a factor of 10 compared to Douglas fir, the tree, which here in Canada was always regarded as like the strongest structural fiber to be used in building. Wow. So when I heard that hemp fiber was 10 times as strong, I was really hooked. I had spent about 20 years of my professional career focused on advanced manufacturing technology for secondary wood processing. In fact, I had developed the technology in partnership with General Electric Factory Automation back in the very late 1980s, early 1990s, which was a pretty early point for AI-focused manufacturing to have surfaced. And, I just became very much attuned to the opportunity that full computer integration, as they called it then, integrated manufacturing, provided in terms of processing, flexibility, and value-added creation. So I patented the technology in 1991, and in 1995 we started to build a new facility for our operations. In 1996, late 96, we finished. So in 1997, as we started to introduce our new technology, our sales were about $37 million a year. By 2001, our sales had grown to 240 million in sales a year. So one of the things that I learned at that point was that if you're a low-cost, high-quality, flexible manufacturer of what are essentially commodity products, you're going to dominate your market. So as it happened, when I was working on the previous technology for the wood processing, I had a strategic partnership with the government of Alberta through the Alberta Research Center. And at that time, you know, they were providing me with a lot of the historical data on the lumber mill prices going back to the, I guess at that point, we're going back 10 years. And there was a young man who I worked with. He was quite pleasant, and I enjoyed working with him. And he was very much into this idea that I was focused on in terms of utilization and you know, maximizing the value of the natural resources that we extract. And you know, we worked together for, I guess, about 6 months. It was very friendly, and then we said goodbye. Out of nowhere in October 2016, I got a call from this gentleman. He had graduated from being a junior bureaucrat to being a senior bureaucrat. From the time hemp had become legal in Canada, the province of Alberta had been, which is a very large prairie-based type farming province. They were very interested in seeing the hemp industry grow, and there was a very strong interest right from the beginning to see hemp grown for fiber. The fantasy was for textiles. Well, between 1998 and 2016, when I got the call, there had been 2 small decortication operations started, and a third one, which was opened by the government of Alberta as a research facility, a hemp research facility, and that was located about 1 hour drive away from Edmonton, the capital of Alberta, in the same town where the Alberta government had their, or has their, agricultural research center. So, you know, I was very interested in you know, going to China. They invited me to go to China as their guest to look at the decortication industry. And oh, I'm sorry. The thing I meant to say was the 2 small decortication operations by 2016 had gone bankrupt. And all that was left was this small research facility. So the government wanted to know why, in fact, what it would take for the hemp decortication industry to thrive. And this fellow, you know, remembering my background in the computer-driven and the AI operations, he contacted me asking me if I would like to go to China to a conference that they were putting on in the Hiliang province, which is the northeastern part of China. And this particular province in China has a very close, long relationship with the province of Alberta. Interestingly, 65% of the dairy cow bloodline in China comes from Alberta, Canada.
Oh, wow.
So in any case, as a courtesy, they invited them, and I was able to go. And what I saw was very, very inspiring, because the people really appreciated the value, the importance of the hemp plant and the hemp fiber. They treated it with great respect. It was very labor oriented. And so one of the first things I quickly figured out is that that would never work in North America. The labor, the attitude was just very different. At the same time, the second realization I had was that this would be ideal for AI-driven hemp stock processing.
Mhm.
And the reason was because it very much focuses on productivity, but it also provides a great deal of processing and production flexibility.
Uh-huh.
And that is something that when you are trying to get the value of the fiber out of a plant, where you don't know exactly what you're going to get before you process, it's a very, very useful capability and feature to have.
Mhm.
So anyways, I came back, wrote the report, and then the next day I founded and incorporated Canadian Industrial Hemp Corporation. So that was 7 years ago, and
Wow.
I have been working with my son JJ for the last 7 years in terms of moving this idea forward,
Mhm.
and working to create a piece of IP for this advanced manufacturing approach that we've envisioned, so that we would have the benefit of the IP in terms of our financing.
Mhm.
In my years, I've come to appreciate that people love innovation, but generally they're afraid of innovation.
Mm.
And from that point of view, with some IP at least attached to it, it shows them that there's a greater opportunity, and perhaps they pay a bit more attention while you're explaining it to them.
Mhm.
So from that, I retained an engineer in Alberta. The engineer had been the actual individual who had spec'd, installed, and operated Alberta's hemp research facility for 11 years.
Wow.
And he had recently chosen to leave the government and go into the private sector as an engineering consultant. So I retained him, and we worked together to create um, what I would consider to be a pragmatic and practical process for um, processing the hemp stock more effectively, finding a way to do it more flexibly,
Mhm.
and essentially to lower the cost of production and maximize the volume through increasing the productivity.
Right.
And we spent about 18 months doing that. I then proceeded to get the patents moving forward, and subsequently, we started to enter the hemp community and to learn what was going on around the world.
Mhm.
And one of the interesting things was that as the more that I learned about hemp, the more fascinated I became, the more committed I became to creating, an opportunity to see more hemp grown in the world.
Mhm.
Because recognizing its unique abilities in terms of carbon sequestration, the fact that it can make stronger, lighter, more durable, more quickly biodegradable substitutes to pure plastic products.
Right.
These things excited me and really made me recognize that this was something worthwhile pursuing, and that there was a great opportunity in doing so. But I guess, Rebecca, what I really enjoyed was the challenge of creating something new. I
Yeah.
think, ultimately that is a part of what has always fascinated me about business. But I will tell you that, the focus of creating our technology was done with a very specific regard, as I said before, to being a low-cost producer.
Mm.
Um, for all intents and purposes, when you're creating hemp fiber from stock, you're creating commodity outputs.
Mhm.
And having been in the commodity business for many years, I understand and I instinctively know that the problem with commodity products are that anybody can go into them. So you have a very unstable market, which is always or usually creating more supply than demand. And
Mm.
it puts good quality suppliers at risk, because it does cost more ultimately to create a consistent high quality output.
Mhm.
And from that point of view, if you're competing against people who are just creating output, ultimately, it just doesn't work out in the margins. So one of the things that we focused on when we were developing our technology was that we would move up the value chain. Rather than just being the producer, the processor of the commodity outputs, we decided we would integrate directly into the secondary production, where again, by definition, we've moved up the value chain, we're entitled to higher margins. But because of our technology, we're able to combine the processing and the production together, which gives you the ultimate quality control and the ultimate flexibility in order to create different products and maximize the value of your input fiber. And so, one of the things I've always said is that technology redefines economics, but the economics redefine the marketing. So the net impact of what we've done has been that the margins that, according to our analysis, we will be able to generate are up to 600 times on a dollar value what you would get with the same production technology without our IP, without our application system.
Wow.
So it redefines the economics to such a degree that it means that you are able to pay your farmers more. You're able to, at the same time, to give your end users lower costs. And because we are very much data driven by having a 100% digitally controlled facility, we are able to use advanced system technologies such as machine learning and predictive analysis so that we can actually optimize not only what we're producing today, but what we will need to produce tomorrow as we get a deeper understanding of our fiber.
Wow.
Get a deeper understanding of our fiber, because part of our IP is the world's first and only hemp bast fiber quality control system. And what it uses is an advanced scanning technology, which allows us not to measure shape and size of fiber per se, but rather allows us to measure the internal material characteristics of the fiber itself. So we're able to measure for specific qualities which identify strength in the fiber. And we're able to identify different qualities which measure adhesion. The technology allows us to identify any color variations because, for example, if you're processing hemp fiber for textiles, having uniform color is a very important variable. And lastly, what we are also able to identify is the moisture content within the fiber itself, so that has two impacts. It identifies the degree of retting that has already taken place, the natural degradation of the fibers inside the stalk, making it easier and better quality decortication. And it also measures the, what's the other thing it measures? It measures the performance productivity in terms of your manufacturing. If it's too wet, the fiber will just tear when you're trying to process it. And if it's too dry, well, our system identifies that with an automated scanner, and it automatically have a sprinkler line that adds additional moisture to kind of lubricate the fibers as we're processing it. So we have a very different paradigm in terms of the way that we approach the processing of hemp stock. What I like to say is that we're transforming hemp stock decortication into hemp fiber optimization.
Wow. So with the system that you have and taking the hemp fiber and then processing it, you're able to identify the end application depending on the qualities that your AI is uncovering and the data that you're getting. So you're able to kind of, okay, well, this fiber is going to go for this end product and this can go here.
We do it a little differently because what we do is that we automatically scan the fiber when it gets brought to the facility. And we do that because we want to know the characteristics before we process.
Oh, that makes sense.
And that's what we do. So then we characterize, we have a blockchain registry that runs right through our entire system. And the data from each bale is analyzed and stored in the blockchain. That data ends up being matched to the specific specifications which we have agreed to provide to our large end users by contract. So then we simply let the system match up the bales that fulfill the specific needs to the specific needs of the end user.
Wow. So where are we at right now as far as the raw materials and getting it to, from the farm to processing it and then to getting it into the marketplace? Where do you see are the biggest challenges in that whole process?
Well, first of all, we have to be clear. If you're talking through the whole process, I mean, you've got a very broad market to, put that into context with. In our particular case, we're focused very much on what I call the bioplastic, capital B, capital P market.
Okay.
And I identify bioplastic in that sense as biocomposites and bioplastic with a small b and a small p. So biocomposite plastics are made with oil-based polymers. Bioplastics by themselves are made with natural vegetable-based polymers.
Mm-hmm.
Now, the point of the matter is whenever you are putting the hemp fiber into the composite polymers known as plastics, that's what actually gives it the strength.
Right.
In fact, I have something here, which I will just show you because I happen to have it right next to me.
Yay.
So this, for example, is a container, and it's made out of plastic, and it's most likely a polypropylene. It could be even a polyethylene.
Uh-huh.
But what I'm trying to show is without much effort, it's highly pliable.
Right.
Here is a container that we made using our biocomposite pellet formulation. And I can tell you that putting in all of my strength, I'm able to deflect it much less.
Yeah.
And whether you're putting that into a oil-based polymer, known as plastic,
Mm-hmm.
or a vegetable-based polymer, known as plastic, it's going to make it stronger.
Uh-huh.
And
so at what percentage can you get the hemp material into those products?
It really depends on the specific applications and what they're being used for. In some applications, you could go up to 40% hemp fiber.
Mm-hmm.
Now, the one that I showed you there was 20% hemp fiber.
Okay.
But let me give you some specifications and numbers that might be interesting.
Mm-hmm.
Last year, in 2021, the global consumption of pure composite polymers with synthetic additives such as calcium carbonate or talc made into products, but just the polymers represented 400 million tons and were worth $400 billion.
Wow.
Now, the compound annual growth expected in that particular market is about 4.5%. So rough and dirty over the next 5 years, about 17 million tons per year in total production.
Wow.
Now, out of the 400 million tons of polymer that are made, 50% of those polymers, about 200 million tons, would be able to be compounded with hemp fibers, hemp and other natural fibers.
Mm-hmm.
And so the point is that by taking even 10% of that 200 million and replacing it with the hemp fibers,
Mm-hmm.
you would be stopping the growth and you would be replacing 20 million tons a year. So 17 million growth, replacing 20 million, you'd have a $3 million 3 million ton surplus.
Mm-hmm.
So when you compare that to natural bioplastics, the entire market for natural bioplastics made from vegetable crops is about 10 million tons a year. No, I'm sorry, it's about 60 million tons a year, which no, it is about 10 million tons a year.
10 million compared to what was the other number?
400 million.
400 million. 10 million compared to 400 million.
Yes, and the natural bioplastics cost anywhere from 5 to 10 times as much.
Right. So
But
it's not
there is
getting
one
into the
thing-
market as much.
Well, there's a number of reasons. First of all, much like corn and ethanol, people don't like to see products that could be grown for food, made for industrial products. So the reality is that, oh yeah, the one important thing I wanted to also add about our technology is when we were developing it with the engineer, it was determined from the beginning that all of the technologies, equipment, systems, and platforms that we would put into the system would be proven in existence, in application, in other processing or manufacturing environments. They would all be large scale and automated. And the reason, of course, is because, again, it's a new technology. People are always afraid of, well, what if this doesn't work or that doesn't work? Well, the point is, all of these pieces have been proven to work. So what we're doing is, and part of our IP is, the way that we put it together is what makes it our intellectual property.
Amazing. Sounds awesome. So, from the progress that you've made over this past 7 years and where you guys are going now, what is your vision for you guys, and then for the market as a whole, to going more into hemp bioplastics?
Well, let me say first of all that it's my belief that the hemp industry, the hemp opportunity, is going to be huge. I think it's going to be way bigger than most people expect. I constantly hear, why is it taking so long? It hasn't taken so long. It's taken 4 years for an industry that was basically locked away from it for 75.
Very true.
And Canada did make some efforts, but at the same time, in order to grow a global opportunity, there had to be a global supply. And so when the US with their farm bill changed their rules along with some of the countries in South America, suddenly there was an opportunity for hemp to be modernized. And from a biocomposite point of view, here's how I see it. The composite polymer plastic industry is a commodity industry. Basically, you're taking hot plastic or hot polymer with additives added for stiffness and different characteristics, and you're molding it into specific product applications. Now, the truth of the matter is that because what it relies on is having the best equipment that gives you the highest productivity and the greatest quality control. So if you go online and check the largest composite polymer thermoplastic companies and compounders, you will see that generally they work on about an 18% operating margin. Now, 85% of their total revenue is their cost of goods sold, and about 80% of their total cost of goods sold are their material costs. Because what else would your material cost be if you're in the extrusion or the injection molding business? It's going to be labor to actually execute, and it's going to be the cost of your material. Well, because it's a commodity, it has to be highly competitive. And so what that means is a large producer may take, or maybe quoting on a $5 or $10 million project, and they could lose that entire project for $50,000 or $100,000.
Right.
Now, because they're working on a 7% net profit, if you can reduce their cost of materials by 10%, that means that you're reducing 10% of 85%, reducing the overall cost by 8.5%. Now, the way I look at it is when one large producer takes a contract and he understands that he was 5 or 6 or 7% higher in cost than somebody else who offered a biocomposite product, which could achieve the same engineering characteristics, and they could still be a cost savings, what will happen is the rest of the industry will quickly follow suit, because the alternative is for them to go out of business. There is just such a disruptive difference in the cost dynamic of being able to produce these biocomposite products that I believe that once the first large supply enters the marketplace, it will become very commonplace shortly thereafter.
Right.
And there will be a huge impact and opportunity on the whole issue of plastics continuing to grow in their market presence. I think it will make a tremendous difference. And the other thing that I would like to mention is that on a personal note, I also believe that biomaterial engineering over the next 10 to 15 years is going to transform even oil-based polymers as we know them today to being capable of natural biodegradation. And that's already starting to take place. So I look at it and say, focusing on the biocomposites is the right short-term solution, because while everybody's trying to figure out how to make only bioplastics because they do biodegrade much more quickly, but the time being lost on the biocomposite development side is too critical at this point. If you think about it, 17 million tons of growth a year takes you from 4 to 500 million in about 5 years.
Right.
In other words, you're growing 25% every 5 years. So the numbers that you start to see are really staggering.
So where's the balance, from the process of what's happening as far as climate change and, trying to do things more natural versus honoring the process of where we've come and what we need to do our due diligence to get to a healthier, place in the way that we produce things?
Listen, Rebecca, I mean, it's the old adage, you've got to walk before you run.
Right.
And the problem is, sure, I mean, and that's why I consider us to be in the capital bio, capital PLASTIK, because our process to create these fiber pellets, which become the critical components in making biocomposite pellets,
right,
will work with oil-based polymers or with vegetable-based polymers. So, that's the difference. I'm not saying that one should be ignored. They both should be pursued, but they shouldn't be pursuing bioplastics only because they're saying, so, I've been asked, okay, so how quickly does a regular plastic product biodegrade? The answer is anywhere from 400 to 600 years. But then the question was, okay, and what about a biocomposite? I said, well, being optimistic, probably somewhere between 60 and 100 years. And they said, well, what good is that? I say, well, it's much better than 600 years.
Yeah.
And again, the numbers that I gave you before, that's the critical thing. Its importance is that people are not going to switch overnight from paying $1,000, $1,500 a ton
it's like
for oil-based polymers to jump into natural-based polymers at 5 to 10,000 a ton.
It's like you have a big cake. You can't take one bite and eat the whole thing. You have to take little bites out of it.
Right. So, that's kind of that's our take on things. That we think that we can make a difference, and by being that much more cost effective, we can, if we were only to be able to save a producer 3%,
Hmm.
people might be more resistant. But the truth of the matter is that 97% of the large um, composite polymer compounders and thermoplastic producers, 97% already have all the equipment they would need.
Mm.
They're already working with the exact same equipment that
Right.
would take to do the biocomposite polymers rather than the pure composite polymer plastics.
Yeah. Yeah. Amazing. Well, Robert, it's been such a pleasure. You're such a wealth of information as far as knowing the facts and the numbers, which I think in our conversation before we said was very important. If we really want to be successful in business, then we have to know, our numbers. And maybe we can end with this question too, that you can give a little bit of insights and maybe some encouragement to other entrepreneurs in hemp, and really, what are some of your tips to make sure that you have the right processes to be successful?
Well, first of all, one of the things that I would say is that if I was a small hemp processor, I would take very close look at what the most applicable, best use of the type of fiber that I produce, what market it would be best used for. Then I would try and find a small scale or somebody who would work with me in terms of marketing and distributing the product.
Hmm.
I think these types of collaborations are going to be very important for the smaller scale producers of
Yeah.
hemp products, regardless of what they are. And by working, with a joint perspective, with a joint goal,
Hmm.
I think that they'll both end up doing a better job financially and in terms of fulfilling customer needs and expectations.
Yeah.
That would be the biggest thing. I think that the other thing that I've written about and spoken to people about is beware of low-hanging fruit. Beware of the easy markets that at first glance might appeal very strong and appealing. One of them
Hmm.
right now is the creation of the hemp herd for hempcrete and also for animal bedding.
Hmm.
They're both wonderful applications. The only thing is that, again, as more and more people get attracted to these attractive markets,
Right.
eventually the demand overpowers the supply overpowers the demand, and the prices start to get pushed down very quickly. I came from that world in the lumber industry,
Mm.
so I'm very sensitive to it.
Right.
It really causes any entrepreneur a huge amount of stress and consideration along the way.
Hmm.
So, that would be my second point. Beware of low-hanging fruit.
Mm.
And just lastly, again, in that vein, Rebecca, I'd like to invite anybody from the hemp industry who'd like to get, some additional information or perspective, whatever I can do to help throughout the industry to get to see more hemp being grown, more demand for hemp to be grown. I'm very, very happy to contribute to that in any way I can.
Awesome. Thank you so much. I appreciate it. It's been
Rebecca,
lovely.
thank you. It was a pleasure and an honor. I appreciate your considering me.
Thank you, Robert. Thank you for listening to Hemp Foundation Talks. Hemp Foundation is a nonprofit social enterprise on a mission to provide solutions for our current ecological crisis. Hemp Foundation and their brand Uki has created a value chain from village farms to the marketplace, utilizing the many benefits of hemp to overcome deforestation, fight plastic pollution, and support regenerative practices to heal our earth. The foundation supports over 250 small village farmers in the Indian Himalayan region. In addition, they employ widows and women in the production of over 500 hemp products for the marketplace, from clothing to food to hemp bags, a large range of textiles, embroidered fabrics, home goods, and even hemp bioplastic. To learn more, visit hempfoundation.net.